In this video, I'm going to do an exercise explaining the proportion test, so testing the proportion, and then in the second video, I'm going to do a question on the on testing the mean. So this is from National Transportation Safety Board. They publish following statistics on the number of automobile crashes that people in various age groups have. So this is about young people. So young people of age 18 to 24 have accident rate of 12%. It means that out of 100 accidents, 12 of them involve people of age 18 and 24. A researcher claims that the population proportion of accidents by young drivers age 18 to 24 is more than 12%. Now, to prove her claim, she asked 1,000 drivers. So 1,000 drivers age 18 to 24 were interviewed. $130 of them were involved in accidents this year. Test the claim, or can we support the researcher's claim? Test the claim using alpha equals 0.05. There are 5 steps that you have to complete in order to test this claim. The first step is to state the null and the alternative hypothesis. This is HO and this is HA. Remember, this is PP, we're testing the proportion, or P node as the book uses here. You must use the equal sign in the null hypothesis, and for the alternative hypothesis it has to be greater than, less than, or not equal to. You can here put P, it doesn't matter. Some books use P node, but either way is fine. Okay, so what we know is the proportion of accident is 12%, but a researcher thinks that it's more than 12%. So what's going to be in the alternative? It's going to be more than 0.12, and this is where the claim is. So this is the first step, which is called stating the null and the alternative hypothesis. Step number 2, guys, is to calculate the test statistic. I'm going to do it in steps, but then later I'm going to show you how to use a calculator to do the whole thing. Now, before we do that, let's see what we have here. We have N, which is 1,000, and the number who said that they were involved in an accident is called X, the number of successes, which is 134. From N and X, we can calculate what we call P hat. P hat is the proportion from the sample, which is X over N. If you divide, you get 0.134. To calculate the test statistic, this is the formula. For students who want to do the calculation, they want to use the calculator, so I'm going to provide you with the formula. P hat minus P divided by P, 1 minus P divided by N. So this is the formula, which is P hat is 0.134. P is the value that we get from the null hypothesis always, divided by square root of 0.12. 1 minus P is the probability of failure, which is what's 1 minus 0.12 will be 0.88, divided by what? 1,000. Be careful as you enter this into the calculator. If you do the math, it's going to be 1.34. The next step. Step number 3 is to calculate the p-value. This is the value that a lot of students ask me about. Let me explain it, show it to you in a visual here. What's the p-value here? Okay, this is z. This is the z line. This is the normal distribution. This is 0. 1.34 will be somewhere right here. Okay, the p-value is the probability of having a value that is more or as extreme or more than the value that we found in the step number 2, which is a 1.34. So it means it's area to the right of 1.34. If you have a left tail test, guys, it will be area to the left, of the z-score. It's as simple as that. So I need to find this area. To find this area, I can find a probability of z greater than 1.34, and I can do a normal CDF. The normal CDF, as you know from previous chapters, you need a lower bound, which is 1.34. Upper bound, it's going to be whatever you want. I always suggest make it 1,000,000 or 100,000. And then put 0, 1 since we are using the z variable. If you calculate this one using normal CDF, your answer is going to be 0.0865. This is the p-value. Now the next step is to make a decision to reject HO or fail to reject HO. Alpha is 0.05. If p-value is less than alpha, we reject HO. Otherwise, we fail to reject HO. And don't change the language. You have to put we fail to reject HO. If we fail to reject HO, it doesn't mean we accept it. We just fail to reject it. Well, my p-value here is 0.0865. My alpha is 0.05, and you agree, guys, that this is bigger. So then we fail what? To reject HO. Number 5, you have to write the conclusion in the context of the claim. Can you support the claim, the researcher claim, or not? Let me write HO and H1 one more time. P is 0.12. P is greater than 0.12. Okay, this is the claim. Let's use some logic here. We cannot reject the first one. And the claim is in the second hypothesis. Can we support it? Well, the answer is no, because I cannot reject the first one. If I were able to reject HO, then I can easily support the claim, but that's not the case. So we say there is not enough evidence at the 0.05 level of significance to support the researcher, and write it down, write the entire claim by researchers, claim that, and just copy and paste what the researcher thinks. And that's the conclusion of the problem. Notice here, if alpha was 10%, then 0.0865 will be less than 10%, then you would reject HO and support the claim. But alpha would have been different. It's 10%, it is 5% here. How do you use a calculator for this problem? You click on TI-84. It's very simple. Click on Stat, then Tests. Then I think it's number 5. So which is 1 prop Z test. Okay, and let's see what we need to enter here. For P naught, you enter the value from the null hypothesis. For X, you would enter 134. For N, you would enter 1000. For prop, you choose the sign from the null alternative hypothesis, which is greater than, and make sure you select it properly, and then you hit calculate. You're going to get step number 2 answer and step number 3. You're going to get Z, which is 1.34. And step number 4, you're going to get the p-value, which is 0.0865. And then you're going to compare a p-value with alpha and make the same decision as we did before. This is a typical example on testing the proportion. This is how you test the proportion, either by hand or by using the calculator.